Chapter 8, System Software. Learning objectives are: explain why a computer system requires an OS, that is, operating system. Explain the key management tasks carried out by the OS. So OS, operating system, part of the system software. What are the tasks or functions? And we will understand the need for typical utility software provided with an OS. There are some with the OS. Show understanding of program libraries. There are modules available instead of rewriting. Now in a library, you go and instead of buying a book, spending money, you go and borrow. Like that, when you want something, you can get from the libraries instead of writing your own program modules. Show understanding of the need for assembly software for the translation of an assembly language program. So we know about assembly language program, but then assembly language has to be translated to machine code. Then for that you need the assembler. The translator of assembly language is called assembler. Then a compiler for high-level language programs. Same task. The interpreter also for high level. It's a different kind of react in different ways. Then we'll be able to explain the benefits and drawbacks of using either a compiler or an interpreter. Justify the use of each. You have to say why you are using the interpreter or why you are using the compiler. You will know how to do that. Then show awareness that high-level language programs may be partially compiled and partially interpreted, such as Java. So partly interpreted, partly. Describe features found in a typical IDE. Point 01, system software. Operating system to control the hardware and interact with application software. What is application software now? Application software is, can you guess? Software which helps the user to perform a specific task, unlike the operating system, the system software. System software has more responsibility. It has to control the hardware, then interact with the application software. Unlike the application software, system software helps to run the system. What system? The computer system. It has to run with the help of this system software. Then operating system defined. A software platform that provides facilities for programs to be run which are of benefit to a user. Then the operating system activities. What are the activities of the operating system or functions? Operating system provides an environment where programs can be run that are of benefit to a user. So programs are beneficial to the user, but how do they run? They can't run without the operating system, because the operating system has to provide all the necessary the environment for the programs to run. Then what are the functions? User system interface. So first of all, it acts as an in-between facilitator for the human to interact with the computer. So that is why interface, intermediate. So one is the CLI, which is called command line interface. And it's the command prompt. Before Windows came, CLI, or the command line interface, which was called DOS. That was the only thing possible. Have a taste of that. No icons, no menus, only the command line. Command only you have to give. You have to remember, you have to memorize. Unlike today, you just click on a picture or an icon, and that will happen. Those days it was not like that. And the first one was disk operating system, the one that was being used before the Windows came. Uh, it didn't come, I think. I'll have to start again. And the prompt, even you can do it. You can have a look at that. Right. Yes, one is enough. If I maximize it now, this is the way we used to work. How? If I type a command called CLS, it will be to clear the screen. So it clears the screen, leaving only the prompt, command prompt. This shows that the CPU is looking at C colon, the C drive, users folder, in the subfolder Dell. So if I want to change to the D drive, there's a D drive, just type D colon. I want to see the contents of this dir, the directory. The term for folder, today's folder is directory, dir. If I want to change to one of these subdirectories, say, okay, the cd backslash, I put dir to show those contents. And then you want to hit or exit, type exit and press enter, it goes off. That is a CLI, command line interface, command prompt. Then came GUI, and it's still there today, graphical user interface. Graphical user interface, GUI. That I don't have to show. Everyone knows only that. Program hardware interface. Another interface, program and the hardware. Because the program is software. So how does software get the hardware to do what is necessary? The operating system has to ensure that the hardware does what the software wants it to do. Software wants certain things done by the hardware, and that both are helpless without the operating system. Programmer need not know how the hardware works. Who? Programmer, you and I. If you are programming, we did not know how the hardware works, but we can get the work done without knowing how it works, big thanks to the operating system. Another task is resource management. When a program has started to run, it is described as a process. Remember that word, process. Since resources are limited, there will be interrupts to a process. Resources are limited. Why? Yes, we have one printer, one DVD drive, one keyboard. Those are the resources, the memory. Those are the computer resources. So when that is there, the limitation, of course, there will be interrupts. Huh? Then, of course, the operating system should schedule these processes. Now, process, remember, processor. It's like 2, 3 children asking the parent, I want this. One will want a toffee, the other one ice cream, another one something else. So like that, because if they are, if like this, if 3 brothers and or else the one parent, 3 parents go, 3 fathers, but 3 children, one each. So then there's no problem, no? The parent just go on giving what the child wants. But if the three children are there, then what happens? One wants something, you give, then another one interrupts. So you have to schedule these, the processors accordingly. Then also resolution of conflicts. When when two processors require the same resources. Example, two programs want to print using the same printer, or uh, two programs want to reside in the same memory location. You know that the memory has to accommodate the program in order for the CPU to run. The CPU is helpless without the program, the instruction, without them coming into the RAM. So in the RAM, there are memory addresses or spaces. So if two programs try to occupy the same space, problem, fight, conflicts. So that has to be resolved. Then we come to memory management. Memory also, you have to have the location, correct location. Memory, you have to protect certain locations. When one program takes hold of one area, another program cannot come and take it. Choosing the organization scheme to achieve the best usage of memory, and also virtual memory, paging, segmentation. What is virtual memory? What is virtual reality? It's not real, but almost real. No? So when virtual memory means you can use programs which are bigger than the memory size. For example, imagine you have 8, 8 GB memory in your computer. But there are 2, 3 programs totaling up to about 10, 12 GB. So does it restrict you to run only one program? Then it's useless. The computer has been evolved and developed so much. Now it knows how to use more memory than what is available, 10 to 12. How? They that is done by this paging and uh, this segmentation, paging. That is, take one section to the memory RAM, keeping the rest in the hard disk. So when pages are there or segments are there, it's easy. Otherwise, you can't. And then what happens when the memory gets full? You send one back to the hard disk and take the required one from another, maybe another program requires. Send one segment of this program to the hard disk. Then take from the hard disk what is necessary. It's managing more memory. The physical memory is 8, virtual maybe 10 or 12. Physical memory you can't increase unless you increase physically. You add on a chip, add another memory chip. But virtual memory is utilizing more, right? More memory than the physical memory has. Then memory usage optimization, deciding which process should be in main memory. So that is also that decision, which program, in order to get the optimum productivity, which program should be now and which program should come next after this. Like swapping, this is like swapping. Send one there, take one here. Another one there, another one. Like imagine you have a table, work table, and it's small, no? Can have a limited amount of files or books. And it's a person, a clerk, or an officer, or some administrator writing, using this table to write letters, to read, or whatever. Imagine that you have to write letters to the students. So the administrator takes the files from the cabinet. There's a cabinet, no? Filing cabinet. Then there all the things are stored. And remember, the CPU cannot access the hard disk directly. CPU has access to the RAM. So the hard disk, from the hard disk, the program should come to the RAM. That is why, right, which now there are two programs running. Which one to come here now? Because in the on the table, as I said, as I started telling you, on the table, imagine you want to write to about 10 students. You take all 10 files and keep on the table. You can't do anything. The table is full, cluttered. Can't do anything. So what do you do? Put what is not necessary back to the hard disk or the cabinet. Then write what is manageable. You keep on the table. Then write, finish. Then still you need to get some other information or some other student. While you are doing this, it's connected. Maybe some conflict or something like that. It's connected to the other student. So you take that file again, but another file which is not necessary now, can put it back in order to make room on the table. That table will go back to that file will go back to the cabinet. Just like that, the hard disk and the memory. Uh, Device management. Device management. What are the devices? We have the printer, scanner, all the peripherals. Installation of the appropriate device driver. So when you install a printer, for example, the computer, the PC must know how to get a printout, how to send the data for the printer to print the way it is required. Because different printers print in different ways, not the letters and the characters that come out, but how the data is converted to printing. That conversion or whatever, that format and all that, those things are different. So if the CPU doesn't know, it can't. That is why you might get, if you have two printers, you may notice that when you want to print, you take a Word document here, or this one, I want to print. All right, coming back to this, here you have the Canon, the name. If I have two printers, we'll have that also. Now here is a fax in Microsoft Print to PDF, Microsoft XPS document writer. So all the printers are here. You have to select. Why is that? If there's no need for the device driver, it's not different, then you don't have to know. You can just say printer. Any printer would print. No, it won't do. So you have to install the device driver. The device driver given by the manufacturer. The manufacturer knows their own secrets or the codes, how how the printer works. The codes are known to them, so they have to give the software which will make the device work. So the under device management, the installation of the appropriate device driver is done by the operating system. Control of usage by processors. You have to control the usage by processors, a certain maybe a printer or a DVD drive, camera, mic, speak, all those things, peripheral, the devices, you have to control. That is also one of the functions of the operating system. Then file management. There is a file naming convention. You can't save. Have you tried saving a file? Then name like this. Try to save this as maybe with today's date. System software and today's date. Today's date is okay. Let's imagine that this is 31st December 23. Let's save. Let's say 31/12/2023. The file name is not valid. Finish. You can't. That means there is a way of doing it. There is a convention. You have to follow those methods. Special characters like at the rate of, and certain things are not allowed. And directory hold structure. What is that? Yeah. Directory is the older term. Now this is called folders and the directory. Older name is directory. The structure, how does it? This is the hard disk. Under that you have this. And if I click this, we have these subdirectories. If I click this, there are some more subdirectories coming under that. And if I click 2023, then we have all these. So likewise, the directory or the folder, the structure, how it is organized. Then access control mechanisms. Access control mechanisms. So how do you, there are file access uh, methods you have learned. We have learned file access methods. Then security management. Provision for recovery when data are lost. So when data are lost, if you have backup or something, or recovery like like undo or something, those things are there. Especially backup and restore. Then prevention of intrusion. So that is like, you know about the firewall. Intrusion is somebody coming unauthorized, uninvited. Those things can be prevented with under security management. Then ensuring data privacy. So that no one else will get this document. And even if it is grabbed or stolen, maybe the data is encrypted and they can't do anything about it. That is the security management. Here you get passwords and password levels, user levels. The same document or some menu options can be given to a certain set of one class of users. One level, then another level. Example, like a hospital or a medical center where doctors have higher level of authority. They can access the data, patient's data. They can edit and update all anything. Whereas the nurses will get also update and something else. Then if there is a clerical staff where they don't need to know about the illness, the background, the medicine given, nothing, just a name, address, and when is it due next, and that kind of information you can restrict. And do you know how to restrict a document? The document can be saved with a password. Here, you take the tools and not save options, go to general options. There you will have file encryption options for this document, password to open. So to open a password, another password can be given to modify. So you open, if you don't give this, if you give a password, then you have to have both passwords. One to open and the other one to modify. But if you don't give this to the person, then only this will enable him to open the document, but no modification, read only. And also here, read only recommended. And the project document, macro security, various things are there. So all done by the operating system. Then error detection and recovery. Errors due to what? Badly written program or supply of inappropriate data. Badly written program is with errors. You have written it badly, or which will arise, which will give rise to errors. It will cause the program to stop. Or supply of inappropriate data. So if for example, a simple example like for age, if you put AB or something like that, and for name, if you put age, the number, so that kind of thing. Supply of inappropriate data, not appropriate. Then devices not working correctly. device is not working correctly also, like printer, the ink is over, or paper jam, no paper, that kind of thing also, then error and the detection and the recovery by the operating system. Maybe it will issue a error message to the user and get the user to do something, or get the user to say yes or no, and the operating system itself will do something. Then also provide error diagnostics. There are certain tools which operating system gives you to diagnose any problems. Troubleshooting. Shut down system in an organized fashion without loss of data. Without loss of data. That there'll be a video attached on your course page that will show you real, how it works, and how the read write head is parked. It's called disk parking. Instead of damaging, when if there's a power failure, or without a battery, or the disk, um, for the laptop, there's a battery, no harm, power going. But there's no battery, or the battery is dead, then if you switch off, take the plug off from the wall socket, what happens? Or in the desktop computers where there's no UPS, you just press the power button, what happens? And what is the meaning of shutdown system? Why is shutdown takes a little bit of time, and how is it safe? How will it protect? So here, some work for you. For each of the above categories of operating system task, each point could be placed in a different category. Different category. But that for each of the above categories of operating system task, each point could be placed in a different category. Make an abbreviated list of these categories and add arrows to show different categories where each point could be placed. So if you think, you can see what you can say security or something like that. Abbreviated list of these categories. So if you look at it well, you will be able to do it. And also it's very important. This is a kind of thing that will help you to answer the exam paper well, because the exam also, when you see now at the moment, you will find that how do I answer this? I was not taught, no. I was not taught. The sir didn't teach us. Teacher didn't teach us. So how to? But that will happen at the exam if you don't attempt it now. So try and get it corrected. That's a different matter. Now we come to utility software. Hard disk formatter and checker. Hard disk formatter and checker. So this is something which will remove existing data from a disk that has been used previously. Not talking about a new one, old disk which was used. If you just delete something, let's say you go to this and then you can't take a risk, we'll take something else. Try and yeah. Okay, my question. I'll take a chance and I'll delete this. I press delete key, it goes off. Yes, it went off. Now, is it really physically removed? No, just a flag. It will just give a flag to indicate to the read-write head or the CPU the next time, don't take this. This is not there. There's no data here. But really, physically, there is data. Now, if I press the undo, Control Z, likewise, but if you do hard disk, the formatter, if you format the hard disk, thereafter you can't undo because it physically removes. Then setting up the file system on the disk and the table of contents. That is on a new hard disk also. When you buy a new hard disk or when you buy a new computer, initially the hard disk from the factory, just out of the factory, it's not formatted. You can't write or you can't write anything on it. It's empty, but you can't write. Imagine like it's like taking a blank paper. You are given a blank paper to write an essay of about 400 to 500 words. Very difficult, right? We'll go this way, that way, up and down, and end up in disaster. But once you rule it, either single rule or square rule in a different format, then you can use it. Same way, there are the table of contents, setting uh, two or three types. So the file system, we talked about the file naming conventions and all that earlier. So this is the file system, how the files are organized. That also will be done by this hard disk formatter. Then partitioning the disk into logical drives. There's one disk, but okay, OS, C colon and D colon. We can give any name here, but this is C colon, D colon. You can have E, any number. Those are partitions, not two hard disks, just one hard disk, but two partitions. Logical, right? So partitioning the disk into logical drives, not physical. Physically, it's one, but logically, the areas, the geographical areas are demarcated. Then also, there is utility software to correct errors. That is, bad sectors. If there are bad sectors, you can mark them as bad, which is either physically damaged the hard disk. You know about sectors, tracks and sectors. Either it's physically damaged or logically damaged. Logically means like it's corrupted. So you can correct those things. This hard disk formatter and checker. Check the disk and make the error corrected. Correct the error. Then there is another utility called hard disk fragmenter. So we talked about sectors. Imagine that file A, file B, and file C. There are three files occupying. File A occupying sector 0 to 3. It's not fully utilized, but you can't write like this. We'll have to take another sector. So sector 4 has file B, that is also not finished. Then sectors 5 to 7, unfinished. File C is there. Now file B deleted. You delete this file B, but this is too big, no? Too big for that. You can't put it there. Next time when you want to expand this, go up to this place, then the balance you can't put here. The balance, otherwise you could have put it here, it's a small one. But now you have to go to another sector, different sector. So now we have file A, file C, again part of the file A there. That is fragmented. That's called fragmented, broken into pieces. So this is the file fragmentation on a hard disk. So there is defrag. There is thing called hard disk defragmenter. So you can see the videos and all that there are. You can watch how these things is done. What happens is the defragmenter will take this file C away. Right? Take this file C and put it in another place. Delete, take this file A and put it here. The balance part, balance file A, will put it here so that this will, it might come here up to about this much. This will be one continuous. The term is contiguous. The computer scientists use the term contiguous. It's continuous. In simple words, it's continuous. So that in one go, you can take this file into memory. Otherwise, you have to go this. This is another sector now. So you have to wait till that round comes and move the hard disk fragment, the read-write head to that place and wait until this comes. So if there are several fragments, then the hard disk gets slow and the computer gets slow. Yeah? You should see the videos, how it will show the read-writed moving, the stepper motor like an actuator and those things, like computer control. Then also you have backup software. You can schedule the backups every week or once a day at the end of the day, or if it is very critical like banks, every hour. And also you can make it save backup or file only when there has been a change. If there is no change, no backup. So that is more efficient. So there is no point if there is no change to backup and duplicate the same thing. Then you have file compression. You remember about file compression we did in chapter 1, the image files, graphic files, and the video files, audio files, how you can compress. And there are two kinds of uh, compression, lossy, lossless, all those things are there. File compression is making the files smaller. Then virus checker. Virus checker is also given part of the utility software, one of the utility software, virus checker. Windows also has defend. Then task 8.02. If you have never used a disk defragmenter or disk repair utility program, can you get access to a system where you can use one? If so, note the changes that are carried out and recorded by the utility program. Now let's see, if you have not used it, how can you get it? Disk. Yes, cleanup is also another one. Disk cleanup also. The next one is defragment and optimize drives here. That is what I'm going to take next. This cleanup is also a utility. It will appear now and ask you which drive to clean. So to remove unnecessary things, the deleted files or the cleanup. Click again. Yeah. Disk cleanup, drive selection. You can select whether it's C or D. Then when you say OK, it will calculate and then show you. It's calculating. How it shows recycle bin only for the moment, only the recycle bin. If I click here and then say OK, that will be deleted. Otherwise, it will show what are the things which are not necessary, useless part. Then you can clean up. And the defragment. Fragment and optimized drives. C drive, D drive. This is the CD-ROM. So here you can see last analyzed, and optimized. Or optimize. Either analyze or optimize, because there are two options, analyze and then show, or else optimize. Now, okay, current status okay, zero fragmented. So there is no fragmentation. How come? Because this does very regularly. This will show when it was done. That is maybe here, change setting. There you can, yeah. Drives are being analyzed on a scheduled cadence and optimized as needed. Frequency weekly, yeah, this is weekly. I have given as weekly. If you want, you can go there, go to this place and change it. Weekly, daily, or monthly. That will do, you analyze it. Then, when as I showed earlier, where there are details, where there are gaps, Then next is program libraries. They usually have subroutines created to carry subroutines, subprogram, or modules. A programmer can use these within their own program. There are usually in the libraries provided by the language. Every programming language has its own library giving subroutines, and they can be used in our program. Built-in functions. There are built-in functions, well tested and documented, or even for like print input in Python. Those are also functions. Those are also these modules, but they are built-in. They can be used. The advantage is well tested and documented. These are tested by worldwide programmers when they are the testing stage, beta testing and all that. They will test and find all the possible errors and correct it. But when you and I write, what happens? The errors might appear daily or weekly, or even after 1 year, errors will come. So that's a risk, not worth taking, because when this is already available, like no need to write your own code and waste time. Own programs, only errors will come only later because only you are testing. Code has to be linked with the subroutines used. It has to be linked with the code for any subroutines used by it. So when you say do this, just give the name, only the name of the subroutine. Where is the code? Defined elsewhere. So you have to connect that. It is possible to carry out the linking before loading the full code into memory and running it. But that will increase the storage space requirement for the executable file. What is storage requirement? Size of the file, because if everything is linked beforehand. It also increases memory usage when more than one process uses the routine, because the same routine can be used by two programs. In that case, that also increases the memory usage. Then DLL, or DLL, Dynamic Linked Library. In memory, this is in memory, right, of the hard disk. The alternative is to use a routine from a dynamic link library, that is DLL. When a DLL routine is available, the executable code just requires a small piece of code to be included. This allows it to link to the routine, which is stored separately in memory. When execution of the program needs it, many processes can be linked to the same routine. And what are the advantages? Let's see. The storage space. The storage space is required because what happens? The DLL, this allows it to link to the routine which is stored separately in memory. It can be used by many. Less storage space, less memory requirement. So connected. When this program requires less storage space, then it requires memory also less. New versions of routines will be automatically loaded. So if there are new versions, automatically it will load, updated and loaded. Disadvantages is if DLL is corrupted, what happens? Or a new version is not tested. New version is updated the only early one, but not tested properly. Then only disaster. So that's a disadvantage. Now we come to language translators, compilers and interpreters, the two main translators. Look at the interpreter first. The interpreter program, the source code, the file, and the data to be used by the source code, all made available. All made available. You have to have everything. Without a single thing of this will not do. Any of these things missing, you can't do. Why? What are the things needed? The source code. That is the program what you wrote. The data to be used, and the source code file and the data to be used by the source code program. Source code is also necessary. The data to be used by the source code also necessary. Both. The interpreter program begins execution, and the interpreter is also necessary for this. The first line of the source code is read. The line is analyzed. That's easy, to understand. Like fetching, this is the fetching time. This is the analyzing. It's like decoding. If an error is found, this is reported and the interpreter program halts execution. It stops. It won't go to the next line. If no error is found, the line of source code is converted to an intermediate code. So something, it changes, converts. The interpreter program uses this intermediate code to execute the required action. So fetch, execute, decode, execute. Right? It carries out the execution also only one line at a time. The next line of source code is read and steps 4 to 8 are repeated. So it goes on like that. It doesn't create a object code or object file or machine code or executable file. That is not provided or generated. Now we come to compilers, which do that. Compilers provide a executable file, program file, machine code. One, the compiler program and the source code file are made available, but no data is needed. Just the compiler program and the source code will do the job, but the translation. No need of the data. Big difference there. The compiler program begins execution, but not the programmer, not our program, the compiler program begins execution, the translation. The first line of the source code is read. Okay. The line is analyzed. Okay, same. If an error is found, this is recorded. The difference. What's the difference? If an error is found, this is reported just on the screen. Error message, and then the whole thing comes to a halt, stops. Here, if an error is found, this is recorded, it doesn't stop. Not the execution of our program, but execution of the translation. It goes on translating. If no error is found, so at the end, if there are no errors recorded, not found, line of source code is converted to an intermediate code. So if this line, when you started line, the first line of the source code is read, no? So if an error is found, is recorded. If no errors, that line of source code is converted to an intermediate code. Intermediate code are the real object code. The next line of source code is read and steps 4 to 7 are repeated. 4 to 7 are repeated. When the whole of the source code has been dealt with, one of the following happens. Right? If no error is found in the whole source code, the complete intermediate code is converted into object code. That's a fine. If any errors are found, a list of these is output. The list of errors will be displayed and no object code is produced. No object code is produced. It won't produce an object code, but it will list out all the errors. The advantages, the programmer, where later on we'll be using as the user, for the user. This is to a programmer of creating interpreted or compiled program. Both advantages and disadvantages. An interpreter has advantages when a program is being developed because errors can be identified as they occur immediately without having to wait for the whole of the source code to be read and analyzed. Did you get it? An interpreter has advantages when a program is being developed because the program at developing stage, if you have to wait for the whole program to be finished to compile, then it's a waste of time. But programmer would like to see the very first line of code, whether there is an error. First line, second line, do about 5 lines or 10 lines and then check. For that, the interpreter is ideal because immediately you will see the error. An interpreter, immediately without having to wait for the whole of the source code to be read and analyzed. An interpreter has a disadvantage in that During a particular execution of the program, parts of the code which contain syntax errors may not be accessed. So if errors are still present, they are not discovered until later. What does that mean? What does that mean? Let's see. The notes, right? There I will explain. So here you can, I will upload this also so that you can go through this. The sectors and various things are there, program libraries, translators here. Now look at this. If mark is greater than 50, print passed. If mark is less than 50, print fail. Looks okay. It looks okay, provided they enter 0 to 100, not minus marks and not more than 100, provided that is done. So this looks okay, no? More than 50 is passed, less than 50 is fail. But what about 50? If you enter 50, there's no grade for that. This is 51, 52, 53 onward. This is 49, 48, 47, less. So what happens is, if now this system, when you are interpreting, if this is correct, that will happen. If this is correct, that will happen. But any day, if you have a fifth, somebody with 50, say after about 1 week or after the first test, second term test, somebody gets 50, then what happens? No result. So there's a problem here. So that disadvantage is there because at the beginning it won't tell you. Only when that error happens, of course, it's not a syntax error. It will not tell. But supposing you have this, there is a error here. There's an error, no? This pass is okay in inverted commas, between inverted commas, the constant, that is okay. But here, the closing inverted commas missing. But supposing no one gets less than 50. Imagine that all are intelligent, bright students like you. So then not less than 50, never. After about 2 or 3 tests, 2 or 3 terms, the last term, somebody gets 45 or something less. Then only it will come this way. The interpreter doesn't read every line, only the path that it takes. So when this line is read and when this line is read, it will encounter the error and stop. Give the error message and stop at that point. Then there is no programmer close by to correct it, only the user in the school. So it's a problem. Yeah, then an interpreter has a disadvantage, another disadvantage. When a program is error-free and is distributed to users, the source code has to be sent to each user. That is the problem. That is a big problem because this is the source code, this is the source code. This also has to go because without this, the interpreter can't interpret. Because there is no object code. It's not already translated. The source code is there. Every time the program is run, only it will translate. Whereas the compiler, it's translated beforehand, and that time only will run. So the advantage for the compiler, that an executable file can be distributed to users. So the users have no access to the source code. So the users will never see this part. If then else and all those things not available for the user. So it's safe. Otherwise, they might change and end up in disaster and they will hold you responsible. So with compiled code, you can't do that. If there is a change to be made, the user has to come to you. The advantages and disadvantages to the user. Now this time it's a user. Now earlier it was a programmer. The user what? Of integrated or compiled program. For an interpreted program, the interpreter and the source code have to be available for each time that an error-free program is run. So for the user also, it's a headache. You have to have that in case if you remove the source code by mistake, then problem. Or if you uninstall the interpreter, problem. For a compiled program, only the object code has to be available each time that an error-free program is run. So that is not cumbersome to the user. Otherwise, the user must make sure that the source code is there, the interpreter is there, the data is. Compiled object code will provide faster execution than is possible for an interpreted program. That is true because there is no time wasted in asking this side and that side. Interpreter is that no translator. If you go abroad, if you don't say Japan, if you don't know Japanese, and the Jap fellow who is dealing with you doesn't know uh, English, then what happens? There has to be an interpreter or a translator. So when that fellow says konnichiwa or something, or if you say aiboan or hello, then that person has to translate and tell the other person. Then the reply again. So like that, the interpreter. But compiler, it's already translated. Already translated. You don't need somebody help. You can look at the book and tell uh, konnichiwa. Or if he says konnichiwa, you can look at the book, the translated book, and quickly you can see, okay, you got the meaning. No need to ask anyone. That is the advantage. Compiled program. Compiled object code will provide, yeah, that's what I read, fast execution, and interpreted program. Then compiled object code is less secure because it could contain a virus. There is, what is the difference here? What's the difference here now? Viruses, as you know, they get attached to exe files or some file, especially exe files, because then it's easy for the virus to come into action when the exe file is executed because it goes to memory. Even a virus has to go into the memory to carry out the work, just like any other program. From the hard disk, it can't spring into action. So then the next one is whether an interpreter or a compiler is used. A program can only be run on a particular computer with a particular processor if the interpreter or compiler program has been written for that processor and processors, and you can't run a program written for one processor in another because every processor has a thing called uh, instruction set. Remember chapter 6 when we did the assembly language, chapter 6, the instruction set is there. So if there is an option available, the choice of an interpreter is justified when a program is being developed because one error in a program can lead to several other errors occurring. One error can lead to other errors, so that can be prevented. An interpreter can detect and correct an early error, so limiting subsequent one. So if you run the interpreter for the first few lines, if there is one there, if you correct it then and there, then the subsequent one will not come. The debugging facilities provided in association with the interpreter speed this process. So there are debugger. What is the debugger? To find the errors. When you find the error, to correct it. Breakpoint. It's called breakpoint. Then you can check the memory contents at that time, the variable data, the values and all that. Then you can error. If there's an error, you can find the error from those pieces of information. The choice of a compiler is justified when the programmer is confident that the program is as near error-free as possible. When you're almost sure, so you can't be sure of a error-free program for a long time, but when you just come close to that, then you can use the compiler. An executable file can be created because these reasons. An executable file can be created then. This can be distributed for general use, like testing and all that. You can. Execution of the program will be faster than if an interpreter were used. So the compiled program runs faster. So towards the end of the completion of the program, then you can use a compiler. But at the beginning, an interpreter will be. Now, Java has a virtual machine, Java bytecode. That has a Java bytecode. When run, the Java bytecode is interpreted by JVM. JVM is Java Virtual Machine. But this is different. This is only for Java, right? Only for Java. But we were talking about in general. In general, for Java, JVM is only for Java. But just to mention that. Then you have what are the features? Features found in a typical integrated development environment, IDE, integrated development environment. In Python, idle. Pretty printing. Pretty printing is one feature of this program editor. Example, Python idle. For example, the Python idle, see figure 8.02, that is this. Yeah, 8.02, pretty print in the Python idle. Particularly color codes, keywords. See, keywords. Then built-in function calls, comments. Comments in a different color. This in a different color. The functions in a different color. Strings and the identifier. Strings are green. It's not shown here. Here, the asterisk, that's green. Comments in this color, things, and the identifier in a function header. Identifier, no color change, that's right. Then identifier, this one, the function name in blue. Yeah? In addition, indentation is automatic. You will know that when you give this colon for counting range or something like that, and you put a colon and you press enter, automatically it comes to this, which is essential in Python. Then context sensitive prompts. Choice of keywords that I can show you in this. This is the Python idle. Supposing I have a to list of elements. If I just say A, it will print just to check how it is. And now if I press A and put a dot, there are context sensitive. Like this list will be different to if I press another thing, a variable or some function or something like that. So from here you can select. Right? So that is there. Okay, will give that also. 1, 2, 3, 4. This is also appended. So this if you can't remember, this is a aid. You put the dot and then the proper the choice will be given. You have to choose the correct word. And dynamic syntax checks. When a line has been typed, some editors perform syntax checks and alert the programmer to errors. At this example, I'll make it bigger for you to see. The blue underline shows that this is a syntax error. There is a syntax error. So this blue line shows after you type and go to the next line, it will show you. Like in word you will show spell errors in red underline and grammar in green underline and that kind of thing. Then expanding, another facility, expanding and collapsing code blocks. That is also there in the, this is of course not a program editor, but I'm just showing you from your own course page, but to know the difference between expand and collapse. This is collapsed. This is collapsed. Here, for the 8 system software, that will be expanded. This is closed, like close, and this is open, expanded. It will show the debugging that is also provided. Interpreter. The breakpoints are there. Supposing you say at this point to break, then stepping through one instruction at a time. You can step one by one and see the variables, how they change and all that. Error and correct it. So here's the definition. Debugging, finding and correcting errors, often called bugs in a program. This is the end of the lesson. Hope you will enjoy this video. Do the homework and watch the other videos, the related videos which are on the website. So till then, goodbye and good luck.